So without further ado, I'd like to introduce Hilary Mason. Hilary is a founder and CEO of Fast Forward Labs, a machine intelligence research company and data scientist in residence at Excel Partners. Previously, Hilary was chief scientist at Bitly. She co-hosts Data Gotham and conference for New York's homegrown data community, and co-founded Hack and Why, a nonprofit that helps engineering students find opportunities in New York's creative technical economy. Hilary served on Mayor Bloomberg's Technology Advisory Board, and she is a member of Brooklyn's hacker collective NYC Resistor. And last night when I had the chance to speak with Hilary, she gave me a bit of a sneak peek into Fast Forward Labs' newest prototype called Pictograph. So if you go to pictograph.us, it's an incredibly cool deep learning tool that will actually analyze your Instagram posts and tell you what you tend to take photos of most often. So I would assume for most of you that would be food or your dog. Hopefully maybe it's this conference and the wonderful people you meet here. So put your hands together and please let's welcome the first speaker of the day, Hilary.
Everyone hear me? All right, good morning. This is my first time to Ottawa, and it's beautiful. It feels like a fairy tale coming the drive from the airport. I actually saw like a hot air balloon and some people in a kayak in a river. And I was texting my sweetie back home, being like, where am I? What happened? This is not Brooklyn. I also, before I actually get into the meat of my talk, I wanted to share a very personal story, because when I was in graduate school, I happened to be housemates with the Brown University campus Red Bull brand manager. And this meant that we had way too much free Red Bull in our house. Like, we actually had the little refrigerator with the Red Bull neon sign in our living room. And we were also broke, and so we ended up having things like Red Bull pancakes, Red Bull and cornflakes. And so I just wanted to share that if you take this Red Bull home and you don't actually want to drink it, Red Bull pancakes are amazing. Red Bull cornflakes, though, not worth it. But you can do a lot of creative things with Red Bull. Also, you can get a hangover from it. I would recommend it. Well, I'm really excited to be here, and hopefully we'll start the morning off with something a little bit thought-provoking. I'm going to speak to you from several different perspectives. So I'm a computer scientist by training, and my work is in machine learning, and I'm going to talk a little bit about what applied machine learning looks like in a startup and industry today. But I also wanted to take an opportunity to take a step back and talk a little bit more about the environments in which we do our technical work, and how those environments both limit and focus the kinds of technology that we can build. And if you do, we will have some questions, I think, at the end, but if you do want to tweet them at me, I'm Mason. All right, everything's working. That's a great place to start. So I generally come at this from the perspective of an optimist, both in terms of my belief in technical progress and in what we can do with that technical progress, and in my core belief in the underlying goodness of humanity. And I hope you'll see that as I go through the talk. But before I really get into the meat, I wanted to make sure that we are on the same page. So it's the year 2015, and we really do live in the future. I'm going to abandon this. And by that I mean, you can actually go on Kickstarter and support a project where you can buy an LED disco suit for your dog. Like, this is a real thing, and the video is actually amazing if you haven't seen it. And here's another example. This is from Reddit. Can I ask how many people are familiar with Reddit? I assume pretty much everyone here. That's everyone here. That's great. Okay, so I don't have to explain to you why this is so ugly. But basically, someone asked this question: if someone from the 1950s suddenly appeared today, what would be the most difficult thing to explain to them about life today? And here's the best answer. It is, I have a device in my pocket that is capable of accessing the entirety of information known to man, and I use it to look at pictures of cats and get in arguments with strangers. Now what this tells me is that technology is in fact changing, but people are not. And I once had a really fun philosophical conversation with a theater professor who was in fact bemoaning the idea that we can what is a really powerful technology? So I've broken this talk into 3 sections, and then I'm going to tie them together at the end. So the first one is just sort of an overview of machine learning technology today, and why I think it's really interesting and very cool. The second is a more abstract discussion of the kinds of organizations that exist in our community today for building technology. And the third is a discussion of how people or professionals sort of play into those organizations, which then build that technology. And this is a really fun talk for me to write. I rewrote it like 3 times, so I really hope it comes across clearly, because I have given many, many talks on technology and machine learning. I have given many talks on organizational process and how you can even think about creating an organization. I've done it a few times. And I've given a lot of talks on, what does a career look like, all of the sort of, what do I wish I knew when I was coming out of school things. But I've never given one talk that tries to tie the 3 together. So it's a bit of an experiment. Thank you for coming along on it with me. And I'm going to start by talking about technology. And again, we really live in the future. And the type of technology that I work with and am personally most excited about right now can be gathered under this umbrella of machine intelligence. And this is a fancy phrase that Google uses for the division where they work on pretty much anything related to data and machine learning. And I like this because it sounds really cool, but also it is not overloaded by the very specific meanings of machine learning or data analytics. Data products are really everywhere today. So I'm going to give you a few examples of ones that I think are really remarkable. The first one is a company called Foursquare. They're another New York startup, but what they have done is actually managed to execute on building an iterative data product. So they started years ago with a game where you would check into a restaurant, and then they'd use the data they got from all of those people voluntarily checking in to figure out, okay, this is what the signal strength looks like when somebody's in this restaurant versus that restaurant. And then they started looking at your preferences. So you check into these places and you leave tips that say, oh, try the Red Bull pancakes, they're amazing. And they learn what you like. And now, after many iterations, they've gotten to a product where you walk into a restaurant you've never been to before, and it pops up a thing saying, you're gonna love the pancakes here. Because it knows both where your phone is, it knows the venue information, it knows the menu, and it knows what's good. And so I've been very impressed with their execution and the way they have iterated on taking the data generated in each subsequent version of their product to make it better, to enable, in a sense, like new data superpowers. Another one that I think is really amazing is this one called Dark Sky. Now, this is an app that takes public in the US government-provided weather data. It gets your GPS location and it makes a micro weather forecast for where you are standing. So people from California are always like, whatever, I don't care about that. But I live in New York where it really does matter if it's going to rain on you in 10 minutes. And this app will pop up a little notification saying it is going to start raining in 10 minutes. It was also made by, at least in the beginning, only 2 people who were able to do some really interesting applied machine learning on the public data to create this app. They have a wonderful blog post about it. Another story that I think is worth relating because it actually involves no fancy mathematics at all was the work done by a woman named Lauren Talbot at New York City's Mayor's Office of Analytics. So she came in under Mayor Bloomberg, who also created the first chief analytics officer. It was a guy named Mike Flowers, and he had been a destroy the mob prosecutor, not a data scientist or an analyst, but he was somebody who got along really well with data scientists and analysts, and he hired Lauren, and she did a project where they looked at ambulance response times in New York City. And it turns out that each precinct has so many ambulances they control. They go out and sort of roam the city and wait for calls to come in. So she went and calculated the optimal place for that ambulance to sit, and then looked at where they actually wait. And it turns out, of course, it was not the same place. But it was, instead of sending a memo to those drivers being like, no, you sit here because it's more optimal, they actually went out and talked to them. And the driver said, basically, well, we sit where we sit because there's a 24-hour bathroom and 24-hour coffee here. And so they went and found somewhat more optimal 24-hour bathrooms and coffee arrangements for the drivers. And then they did another thing where they just counted the number, they asked a series of questions when you call the emergency number, and they just figured out how to reorder the questions to get the call handed off to the ambulance folks sooner. Between these two interventions, they managed to reduce ambulance response time in New York City by 1 minute. She gave a talk about this at Data Gotham, and it's on YouTube. I'd encourage you to watch it. I think it's a remarkable data product because for one thing, it's actually saving lives, and for another, all it involved was taking data from here, combining it together, counting it, and then going and talking to some people. Something so simple, any organization should be able to do it, right? Okay, so my last example of a data product is Google Maps with the traffic view. And I'm just going to ask, what is the most remarkable thing about Google Maps traffic view? This is obviously a trick question, I wouldn't ask you. It is so boring, right? So if you think about the technology that is going into creating this product, first visually, it's a metaphor that we are all trained to understand since we're really little kids. You look at this, you know immediately what it means. There's traffic on this block. The green means there's no traffic on that block. They are doing things as advanced as making predictive models of traffic off of historical data, which they combine with real-time data from people's phones in their cars as they drive down the street. It is really mind-blowingly complicated, and it leads to this thing that is so simple and boring, we look at it and don't even give it a second thought. I think this is one of the most remarkable data products that exists today, because it is able to enhance our decision-making ability in the real world with real-time relevant information without us even knowing anything about how it works or what's going on with this technical system. It's really cool. So you might ask, why is 2015 a great year to think about data products? Why wasn't it 2010 or why wasn't it 2005? And there are a bunch of reasons for that too. One is that computers are cheap now, or that we have the infrastructure to actually process things. But it goes beyond that, because computers are not just cheap, they're cheap enough to play with. And I used to work at a social media analytics company, and we had billions of links coming through the system, people clicking on those links. And it was one day we set up a new Hadoop cluster install, and we were trying to figure out what job to run to sort of make sure everything was working. And we came up with the idea of figuring out whether people actually click on more photos of cats or dogs on social media. And so we ran that for 8 hours on all of our data. And it just occurred to me that if we could spend our incredible compute power on something so absolutely frivolous, we have really entered an age where you can start to be very creative with data. And the answer, by the way, is dogs. So yeah, right? We also have the data. So as that photo of this is the whitest of white men in data science. But as our photo of President Obama illustrates, right? The data is being collected. It is going somewhere. Whether we're happy with that is a whole other question I'll get into in a little bit. But the data exists, and it is cheap enough that pretty much anyone, even someone at a little startup without a big budget, can actually afford to collect and analyze it. And if you need to start from scratch, data is out there to be found or generated. And the last reason this is happening now is because once we collect the data and we have the computers, we actually sort of know what to do about it. So I talked to a lot of companies who think their data is beautiful and unique, and that no data like their data has ever been collected before. But it turns out that the vast majority of information being collected is being collected through transactions from human behavior, mostly online, and then in some cases from sensors or from other logistical apparatus. And that data all has a lot in common. People are really not that different. If you're looking at an e-commerce application or a social media application, consumer behavior is pretty consistent. And so things you learn that apply in one domain often apply in other domains. And this is a really good thing. Even though people might want to feel like their data is somehow unique, it probably isn't really. And none of this is new at all. And so it's one of my personal hobbies to read a lot of like history of science and computation and try and figure out where we got to, how we got to where we are right now. Specifically when it comes to computing, and you always uncover these really interesting stories, like the first punch cards, which were created by a guy named Herman Hollerith to count the 1890 US Census. They were the size of US banknotes at that time. And they were that size because he got a bunch of surplus treasury boxes to store his punch cards in. That's why. And then here's a woman named Mary Casey who ran her own all-female like business accounting firm on mainframes at the time, holding the second generation of punch cards, which was roughly the same size. You can actually go look, you can still buy these punch cards. It was standardized by IBM, which is what Hollerith's company eventually became, all because of the size of currency. That's why they were the size they are. And US currency at the time was bigger than it is now. Not as colorful as Canadian currency, though. This is another thing that, this is a pretty young audience, so maybe this won't work here, but somebody on SuperUser, which is like the Stack Overflow for system administrators, was asking this question. Why in Windows do you start with C? So you start with C, and then everything goes down from there. What the heck are A and B for? And I see some people are smiling here, so anyone smiling, you can ask them. But yeah, it's worth knowing your history to know how you got here. Another one I uncovered recently, and I couldn't find a great webpage for it, but it turns out there's no standard definition of pi in C++. Now you might think, of course there's a definition of pi in C++. That is a non-standard extension that you are using. Now why is there no definition of pi in C++, even though there are definitions of other constants? Well, it turns out that they got around to standardizing constants later, and a lot of different implementations were already of that. So this is an iPhone selfie. It's a Creative Commons photo. I don't know if you can read the link, but I'll put it up later as well. Basically, we are limited in the applications we can develop on this platform to what the APIs give us. And I believe that actually is limiting the innovation that can happen in mobile technology, whether it's iPhone or Android. Somebody needs to make an open mobile OS. And the incentives matter. This is true both technically and non-technically. When you build companies and you dole out ownership and you look at who is paid for what and who is rewarded for what, those incentives ultimately drive culture, which ultimately drive the product you build. And so I spent a year with a venture capital fund called Excel Partners, and they are absolutely wonderful. They invest in a bunch of data-driven companies. Some of them are companies like Cloudera, which does infrastructure. Some are companies with data products, like Facebook being probably the most famous one. Some of them are companies like a billion-dollar media brand that makes action movies that you would think should not even have anything to do with venture capital. But I did that in order really to learn how that side of our ecosystem functions and whether startups are indeed where the most innovative ideas come from and how they go from being an idea to an entity to a big thing that can actually affect culture. And so when we think broadly about where creative ideas come from, a lot of the time we think they come from academia and we think they come from research. But I've been a computer science professor and I can tell you that in this place you are incentivized to publish and the work you can do is limited by what you can publish. And so you are very free within that restriction to work on whatever you like, but it is still a very strong restriction. And once you are far enough along to have tenure, you have students who need to publish. And so it's not like that ever leaves you. You also are now competing for grant money, which is its whole own fun process. And you're competing for grant money in a world with less and less of it there. And so while we may argue that a lot of the interesting research and creativity around technology comes from academia, it is focused in a different way than what we want to see in the market necessarily, and it's also limited in its own way. Not to be disillusioning, but you might say, okay, well, what about big companies? They can take risks. They're big. They've got money. But it turns out risk-taking is very much frowned on in larger enterprise. And even companies that are not large enough tend to end up in risk avoidance modes. And it's because they have a lot to lose. And people don't get promoted for taking risks and failing. And taking risks is, as a data scientist, we're all about probability. That actually means that there is no absolute positive outcome. And so you tend to see people sort of build mechanisms inside of enterprise for risk-taking. Like they will create a startup inside a big company, they'll create a research lab where people are explicitly allowed to not produce ROI. Or they'll work with third-party companies to indulge in some of their risk-taking, or they'll start their own venture investing arm because they cannot do it directly, their incentives do not allow it. And so then you might say, great, well that's why we have startups. So like scrappy little people taking crazy risks and sometimes hitting it big. But it's really hard to do that. And it's hard to do that because you are taking a technology risk at the same time you're taking a business risk. So if you want to start a new company, most startups are not actually built with novel technology. They're built with commodity technology with a novel product or business model. And so to alleviate some of that risk, we've built other mechanisms, things like venture funding, things like accelerators. But the over-marketing of these mechanisms has essentially led to sort of a homogenization of the kinds of products people build because it is very hard to do these two things at the same time. So if I can give you any advice about creating an organization, it is only think for yourself and love cats. The other thing I've spent a lot of time thinking about lately is we tend to think about each startup story as if it is a naive, and I mean that in the statistical sense, as in not a dependent variable. Like that startup exists in a vacuum. And that is actually like absolutely not the case. Each startup, each project, and this is true for nonprofits, for open source projects, it cannot exist without the context around it. So one thing that might be a great idea this year might be a terrible idea 2 years ago or 2 years from now, but it might work so well this year. And I happen to work at a company called Bitly, which is short links on the social web. All it does is take long URLs and make it short, and then you share them. And if you think there was any other time than that moment in 2008 when that company could have been started, like I just can't imagine it. The idea that that thing existed and got to its scale was an absolute accident. I shouldn't say accident, it was an absolute bit of luck that happened to occur because of Twitter taking off at exactly that moment, because of other platforms taking off, because people were fairly naive about data collection at the time. And that could not happen today. You could not start that business today. You certainly couldn't get it to scale. And so whenever I think about an opportunity around a project, or whether it is the right moment to deploy, whether it is a conference, a new open source project, a new company, it is really looking at the context fact, this is one of my favorite bug reports of all time. So it is a bug report on the iconography of the cheeseburger. And it is extremely specific about what is wrong. And I put this in here to illustrate, even when you get people together, they do not agree. So there is a wonderful debate in the comments on this bug report about what a cheeseburger should actually look like. This is the kind of constructive bug report we should all be going for. Also cheeseburgers. All right, so I know we have 7 minutes left. I'm at the last bit of this talk. Is everyone still with me? We've been very quiet this morning. Okay, great, thank you, those in the back. So I want to talk a little bit about Fast Forward Labs because this is a company I started a little over a year ago, and it is my attempt to tie these 3 philosophies together. So just to remind you, the technology of machine intelligence, that is building Skynet, but in a good way, with a philosophy of organizational design, and really great people who come from a variety of interesting backgrounds. So what we do is, this is sort of the business version. We focus on innovation opportunities through data and algorithms. And the very short idea is that a lot of companies, particularly those big enterprises, have been running their businesses for a very long time. They've been gathering data for a very long time. They have really interesting data. They don't know what to do with it. And in many ways, they're trying to plan around it without the benefit of expertise in machine intelligence and data science on staff. And so what we do is basically act like an R&D department, where we're sort of in the middle of the academic research community. Our team is all sort of reformed academics, people who started a career in academia in one discipline or another, and then basically decided for whatever reason at some point along that path it's not for them. And went and actually built product in industry at companies. And the team is also a mix of really different backgrounds. I'm the only computer scientist. We have 2 astrophysicists. We have an explosives expert from Iowa, a woman who did her work in fashion analytics, conceptually, this is how it works mathematically, this is what walls you're going to run into if you try and engineer with it today. Here's what's out there in the market if you want to buy this versus build it yourself. And here are the ethical things you have to worry about when you start to build systems with this technology. And we found it's been actually amazing that we've been giving people inside large enterprise an excuse to actually talk about ethics. And not just ethics in the context of what am I legally required to do for compliance, but ethics